walk by, I see different people with different emotions. As I turn right, some people are excited. Someone is experiencing fear. As I turn left, I see a girl laughing. A baby crying, and a beautiful girl smiling.
So now, let's talk about emotional behavior. Emotional situation arouse the autonomic nervous system, which has two branches, the sympathetic and the parasympathetic. The sympathetic nervous system prepares the body for brief, vigorous, fight or flight situation. The parasympathetic nervous system increases digestion and other processes that save energy and prepare for later events. However, each situation evokes its own special mixture of sympathetic and parasympathetic arousal. For example, nausea is associated with sympathetic stimulation of the stomach, decreasing its contraction and secretion, and parasympathetic stimulation of the intestines and salivary glands.
So, how does the autonomic nervous system related to emotion?
Common sense holds that first we feel an emotion, which then changes our heart rate and prompts other responses. In contrast, according to James Lang theory, the autonomic arousal and skeletal actions come first. In common sense view, the first is frightening situation, second is fear, and the third is increased heart rate. In James Lang theory, the first is frightening situation, second is increased heart rate, and lastly is the fear. When William James had said that arousal and actions lead to emotions, what he meant was the feeling aspect of an emotion. That is, first is event, second is appraisal or the cognitive aspect, third is action or the behavioral aspect including physiology, and lastly, emotional feeling or the feeling aspect. The James Lang theory leads to two predictions. People with weak autonomic or skeletal responses should feel less emotion, and causing or increasing someone's responses should enhance an emotion. Let's consider this evidence. People with damage to the spinal cord are paralyzed from the level of the damage downward. People who cannot move their arms and legs certainly cannot attack or run away. Most of them report that they feel emotions about the same before the injury. This finding indicates that emotions do not require feedback from muscle movements. However, paralysis does not affect the autonomic nervous system, so it remains possible that emotional feelings depend on feedback from autonomic responses. The amygdala, shaped like an almond, is responsible for multiple emotional responses like love, fear, anger, and sexual desire. Shippensburg University states that in animal studies, stimulation or removal of the amygdala alters emotional response. Electrical activation causes aggression, while surgical removal results in indifferent emotional reactions. Therefore, damage to the amygdala can result in abnormal emotional responses, and overstimulation causes excessive reactions. The hippocampus is another part of the limbic system that sends information to the amygdala. One of the memory processing centers of the brain, the hippocampus interacts with the amygdala when a person has memories with emotional ties. Hypothalamus. The hypothalamus, also part of the limbic system, feeds information into the amygdala. Shippensburg University states that the hypothalamus acts as a regulator of emotion, controlling levels of sexual desire, pleasure, aggression, and anger. Prefrontal cortex. The prefrontal cortex, located near the front of the head, is involved in decision making in response to emotions. The Canadian Institute of the Health Research states that prefrontal cortex controls what decision a person makes when faced in an emotional reaction and also regulates anxiety. Ventral tegmental area. The ventral tegmental area is also involved in emotions and love, particularly in how a person perceives pleasure. Dopamine pathways are located in the ventral tegmental area. Dopamine is a neurotransmitter involved in mood, and increased levels elevate the person's level of pleasure. According to the James Lang theory, emotional feelings are from the body actions. If your heart started racing and you started breathing rapidly and sweating, would you suddenly feel an emotion? Well, it depends. If you had those responses because you ran a mile, you would attribute your feelings to emotions. If we want to test this hypothesis, how we could get people to smile? Yes, of course. Come on, let's try. Can you smile? Are you happy?
Yes, of course.
Clever researchers find a way to get people to smile while concealing the purpose of the study. It is a method you could easily try on your own. Come on, let's try. Hold a pen, put it in your teeth or in your lips. Read your comic strip in your newspaper. And put an X for not funny and check for very funny. So now, let's see the results. However, although smiles and frowns slightly alter happiness, smiles are not necessary for happiness. People with very rare condition called Mobius syndrome are unable to move their facial muscles to make a smile. They nevertheless experience happiness and amusement, although they have a trouble making friends because other people react to the lack of smiling. Another hypothesis relates the two hemispheres of the brain to different categories of emotion. Activity of the left hemisphere, especially its frontal and temporal lobes, relates to what Jeffrey Gray called the behavioral activation system, marked by a low to moderate autonomic arousal and a tendency to approach which could characterize either happiness or an anger. Increased activity of the frontal and temporal lobes of the right hemisphere is associated with the behavioral inhibition system.
A runaway train is heading towards 5 workers on a railway line. There's no way of warning them, but you're standing near a lever that operates some points. Switch the points, and the train goes down a spur. Trouble is, there's another worker on that bit of track too, but it's 1 fatality instead of 5. Should you do that? Many people think the right thing to do would be to switch the points, to sacrifice 1 to save 5, since that produces the best outcome possible. Now imagine the train heading for the workers again. This time it can only be stopped by pushing a very large man off a bridge. His great bulk would stop the train, but he'd die. Should you do that? Most people say no. But why not? Both thought experiments are cases of sacrificing 1 to save 5. What the trolley problem examines is whether moral decisions are simply about outcomes or about the manner in which you achieve them. Some utilitarians argue that the 2 cases are not importantly different from each other. Both have similar consequences, and consequences are all that really matter. In each case, 1 person dies and 5 are saved, the best option in each harrowing situation. But lots of people say they would switch the points, but they wouldn't push the man off the bridge. Are they simply inconsistent, or are they onto something?